When a primary alcohol is treated with chromic acid in water, a carboxylic acid is the product. The mechanism starts out just like it would for a secondary alcohol. Start with chromic acid. And that chromic acid is activated by protonating it with H3O+. Now, with our activated chromic acid, our weak nucleophile, the alcohol, attacks the chromium, and the electrons go up onto the oxygen. And now we have our good leaving group, the chromium, attached to the oxygen. And that's when we eliminate. Water comes, takes this proton off. The electrons from that proton swing over, like on a hinge, to be between this carbon and this oxygen. The electrons from the chromium-oxygen bond get kicked onto that chromium. Irreversible process. And you end up with a protonated aldehyde. And this is a good electrophile, capable of reacting with water, and then a quick proton transfer. Yields this molecule with two OHs attached to the same carbon. This is referred to as a hydrate, or a gem diol, which is short for geminal diol. This has a motif on it that's very similar to what we've seen before. Right here, we have an H, carbon, oxygen, H. This is what chromium reagents oxidize. Here we have an H, carbon, oxygen, hydrogen. This can be oxidized further by a chromium reagent. So our active chromium species, we've already shown it being activated in this step before. We don't need to show it again. But one of these chromic acids comes in that's activated, and one of the two oxygens, doesn't matter which one, attack the chromium. So the electrons go to the chromium, and the double bond electrons go up to this oxygen here. like so. And you also have another OH. And then water comes in. We have pretty much the same situation as we have up here, where we have an H, C, O, Cr. Here we have our H, C, O, Cr. Now water comes in, steals this proton. The electrons go between this carbon and this oxygen, and the electrons from the oxygen-chromium bond go onto the chromium. Reversible step. And we end up getting a protonated carboxylic acid out of it. Water, to finish up the mechanism, comes in, deprotonates carboxylic acid, protonated carboxylic acid. That gives us final product with the carboxylic acid.